Hi guys, this is Gayathri and I'm going to be teaching you guys about section 3.5, which is how to find the implicit derivative and the implicit second derivatives. So the implicit form, it's a really simple concept. So normally we're very used to seeing the explicit form, which is seeing the y is equal to some term of x, and we're seeing the x and y terms on different sides of the equation. So y is equal to 2x or y is equal to 5x squared plus 2. And the implicit form is bringing the y and the x terms, the x and y terms together to one side and the constant in the other side. So for example, 2x plus 3y is equal to 0. So when we're solving for a quadratic form, we're usually bringing the x and y terms together, if that's going to help you guys understand what an implicit form is. So in this diagram, we're seeing the same equations, one in the explicit and one in the implicit form. So there are a few really simple steps you can use to find the implicit derivative. And keep in mind that y prime is equal to dy over dx, okay? So the first step you want to do is to change the equation from an explicit to an implicit form. And that we discussed is by bringing all the x and y terms to one side and leaving the remaining constants on the other side of the equation. After that, you have to find the derivatives of both sides. So for the derivatives that do not contain a y term, you don't have to change anything. You have to find the derivatives the same way you did for the past couple of weeks. But when the term does contain a y and you're finding a derivative, you want to replace all the y's, the derivatives of y's, and you want to attach a y prime to each term. So for example, if you had to find a derivative of 3y squared, you'd have 6y. You would have the derivative, so you get 6y, and you want to attach a y prime to that. So you get 6y times y prime. After that, you want to transfer all the y primes to one side of the equation and then solve for y prime. And you might want to keep in mind for any values of x or y that would make the function for y prime undefined. So in this diagram, I have a step-by-step method for finding the implicit derivative. So you get y is equal to 5x squared plus 2 as your equation, and it's in an explicit form, so you want to make it into an implicit form by arranging all the x and y terms on one side and the constants on the other, which is exactly what we did. So you get 5x squared minus y is equal to negative 2. So after that, the second step is to find the derivatives of both sides. So for 5x squared, you don't have a y term at all, so you do it the same way you did for the past couple of weeks. So 5 times 2 is equal to 10, and 2 minus 1 equals to 1, so it's equal to 10x to the power 1, minus. So normally, while you would be saying 10x minus 1, you have to remember that you're finding the derivative implicitly, and by doing so, you have to attach a y prime, since you are finding the derivative of a term that contains a y. So you get 10x minus y prime is equal to 0, because any derivative of a constant is equal to 0 always. So you get 10x minus y prime is equal to 0, and you want to solve for y prime by by bringing the 10x to the other side and dividing by negative 1. Okay, so here's our first question. Find y prime for x squared minus 4y cubed plus 6y squared is equal to 31. So this equation luckily is already in implicit form, so you don't have to do anything there. And afterwards, you have to find the derivatives of both sides. So since x squared does not contain a y term, you can find the derivative as always, which is equal to 2x minus. So 4y cubed, the derivative is 12y squared. And since 4y cubed contains a y, and we're finding the derivative of that term, you had to attach a y prime. So it's equal to negative 12y squared y prime plus 12y times y prime is equal to 0, because the derivative of 31 is equal to 0 always, or any constant for that matter. And then now you have two terms that contain a y prime. So you want to group those together the same way you would group, let's say, 12x plus 3x is equal to x times 12 plus 3, same idea over here. So y prime times negative 12y squared plus 12y, because those were the two terms containing a y prime, is equal to negative 2x, because negative 2x was the only term that did not contain a y prime. So then you'd be solving for y prime by dividing both sides by negative 12y squared plus 12y. So you might want to keep in mind that y cannot be equal to 0 or 1, because that would make the denominator equal to 0, and therefore y prime equal to be undefined. So now find the derivative of y implicitly for e to the power y sine x minus sine xy is equal to 2. So this might seem to be a little complicated, a little advanced, a little overwhelming, but we can walk through this pretty easily, and I'm confident you guys will understand this. So since this is already in an implicit form, because you see both x and y terms on one side and the constant on the other, you have to find the derivatives, and e to the power y sine x is two different functions, so you want to use the product rule for this. So you get e to the power y times the derivative of sine x, which is cosine x, plus, because that's the product rule, e to the power y times sine x. And because we're finding the derivative of e to the power y, which contains a y, and you're finding the derivative of that term, you'd attach a y prime to that term. So you get e to the power y sine x times y prime minus, so the derivative of sine xy is equal to cosine xy times xy prime plus y. And it might be a bit of a mouthful right now, but later you learn that it's because negative cosine xy times xy to prime plus y is equal to negative xy prime cosine xy minus y cosine xy because of the product rule. So afterwards, you can see that you have two terms that contain y prime, and you want to separate those two terms and bring it over with the y prime to one side and bring the other terms to the other side. And you'll solve for y prime by dividing both sides by e to the power y sine x minus x cosine xy. And you might want to notice that x cannot be 0 because sine of 0 is equal to 0, and 0 times cosine of anything is equal to 0. So the second derivative, it's actually very simple. You want to use the same rules and the same steps that you used to find the first derivative, except you're going to be using it to find the second derivative. So I'm going to walk you guys through this one. So our equation would be finding the second derivative of y implicitly for 5x squared plus 6x cubed minus x squared y is equal to 2. So this equation is already in the implicit form, so you don't have to do anything over there. So next you have to find the derivative, which 5x squared plus 6x cubed both of those terms don't have any y terms in them, so you can solve those derivatives as you normally do. So that would be 10x plus 18x squared minus, then x squared y, you want to use the product rule for this. So you get x squared times the derivative of y, since it contains a y, x squared y contains a y, would be y prime. So you want to attach a y prime to that. So it's equal to x squared y prime plus 2x times y is equal to 0 once again. So you want to clean that up a little bit, and you're getting 10x plus 18x squared minus x squared y prime minus 2xy is equal to 0. And since only one term, negative x squared y prime, contains a y prime, you want to bring that over to one side and move all other terms to the other side. So you get y prime times negative x squared is equal to 2xy minus 10x minus 18x squared. And you want to divide both sides by negative x squared, and then you can clean that up a little bit if you want by dividing an x. So to find the second derivative, it's really simple. You want to use the same steps, but one thing you want to do first is multiply the negative x squared to the y prime. So y prime is equal to 2xy minus 10x minus 18x squared divided by negative x squared. So you're bringing the negative x squared to the y prime side. So you're getting y prime times negative x squared is equal to 2xy minus 10x minus 18x squared. And you want to find the derivative of both of those sides. So y prime times negative x squared, they're two different functions. So you want to use the product rule, and you're getting negative 2x y prime minus x squared y double prime. Because remember, the derivative of y prime is always going to be y double prime, is equal to 2xy is also once again a product rule. So you get 2xy prime plus 2y minus 10 minus 36x. And you want to solve for y double prime. So you want to bring the y double prime to one side is equal to 2xy prime plus 2y minus 10 minus 36x plus 2xy prime divided by negative x squared. And you want to clean that up a little bit, and you get y double prime is equal to 4xy prime minus 36x plus 2y minus 10 over negative x squared. So that's it, you guys. Thank you for listening, and it's a pleasure to teach you guys always.